Hey folks, Mr. Hartzler here, and I wanted to talk to you about the quadratic formula. That's what's up on the screen. Let's go on and start some examples. Well, I guess first we have to look at the target. So our target is that you can solve quadratic equations using the quadratic formula, and it's right there up on the board. So if you want to write it down somewhere, stop the video and take a screenshot or something, or write it down. I don't care what you do. Let's go on to the next one. So now we're here. What are the solutions to the equation? Looking at that, looks maybe a little bit complicated. We have 3x squared minus 4x plus 9 equals 0. So one of the strategies that we've done in the past is factor this. We'd factor it, so we have it up into each of the two pieces in this case because it's x squared. We set each piece equal to 0. We don't want to do that because maybe it's cumbersome. In this case, it's 27. What two things multiply to get you 27, but add up to get you 4? Nothing good, I think. So instead, we're going to do the quadratic formula. First thing I'm going to do is I'm going to go to the last slide. I'm going to write it down from there, and then we're going to do some plugging in. All right, so now I have the thing written. I now am going to take each of these pieces and substitute them in. I have my A, my B, and my C. I'm going to plug each of those in to this formula. Now, I need to actually do some simplification. I'm actually have to do some work here. Sometimes, I will admit, this does require a calculator. On all of the tests that I will do for my students, it won't. I'll make sure all the numbers come out kind of cute, so it'll be okay for you. But let's keep going, and let's see if we end up needing one or how it all looks. So double negatives, simplify to a positive 4. Keep that plus or minus there. Negative 4 squared is going to get me a 16. Minus 12, I'm actually going to write all that down. 16 and then minus 12 all over 6. So I'm going to simplify underneath the radical, and I end up with 4 over 6. Okay, so now I know the square root of 4. Let's write that down. Plus 4 plus or minus 2 over 6. Now this is going to get me two different cases. I have the positive version and the minus version. So x equals 4 plus 2 over 6. Well, that just ends up being 6 over 6. And then I also have x equals 4 minus 2 over 6. And that is going to get us 2 over 6, or 1/3. So those are going to be my two answers. 6 over 6, I didn't write that simplifies to a 1. Those two things, barely didn't get cut off by my face. I'm going to write it in the center here. So our two answers are x equals 1/3 and 1 right there. Those are our two solutions. Just to verify everything, I would plug all of that in and make sure it still works, but I'm going to assume they're good for now and keep on trucking. Now we're here. Let's do this one. Again, I'm going to write down the quadratic formula. Then I'm going to substitute in all of these letters here, my A, my B, and my C. Next thing I need to do is start doing some simplifying. So I'm going to do some multiplication around in here and cleaning things up a bit. Now I'm here. Now I need to keep simplifying. I'm going to add up the stuff underneath my radical. That's called the radicand. Or sorry, that's called the discriminant, is the stuff underneath my radical. Now, I need to try and take the square root of 529. Square root of 529 is just 23. Let us simplify now with knowing that information. So x equals 7 plus or minus 23 all over 12. Then again, I need to split this up into the two cases. X equals 7 plus 23 over 12. And x equals 7 minus 23 over 12. And then I can simplify this a little bit. They each have a 3 in them, so that simplifies to a 10 over 4. Oh, so they actually each had a 6 in them. So I'm going to divide it by 2 again, and I'm going to get 5 over 2. So 5 halves on that one. This other one here, I need to go sideways because I can't go down. 16 over 12. I'm going to divide both by 4, and I get a negative 4 over 3. So my two answers are negative 4/3 and 5 halves right there. Awesome. Let's go on to our next one. So here, it's more just words, right? There's no problem for us here. But identifying the number of real roots. The number of real roots, I have to look at my discriminant. That's the stuff underneath the radical. To determine the nature of the roots. By nature, I just mean if they're real or imaginary. And if you look at that first case, right here, b squared minus 4ac. Remember, my formula. So the stuff underneath that square root, the b squared minus 4a, if that is greater than 0, that means I'm taking a square root of a positive number. That's going to get me 2 real roots. Now, if that all equals 0, well, what is the square root of 0? Just 0, which means I'm going to be adding, plus or minusing 0, which isn't going to change it. That gives me just one case, one real case, one real root from the one case. But now, if all of that ends up being less than 0, less than 0 would mean I'm taking the square root of a negative number. Taking the square root of a negative number gives me non-real or imaginary roots. All right, I'm going to have i's involved because remember the I equals the square root of a negative 1. So that will be involved if all of this ends up being less than 0. Let's go do some examples. All right, we have a word problem. Don't let that frighten you. Word problems are really not that bad. It's just the real world version of how this math even applies. So Aliana is about to serve and tosses a tennis ball straight up into the air. The height of the ball at time t is given by that formula. Will the ball reach a height of 4 yards? Okay, so if I plug t in, if I plug my time in, does it ever get to 4 yards? Because my ball, I'll just do a little graph here. I would suppose probably that it goes up and then comes back down, right? That's typically what balls do on Earth because, gravity. So do I ever hit a high here or anywhere in here really of 4? Well, let us see here because I have these 2 spots probably. So let us just see. Let's if it ever hits a height of 4 yards, then there's a time at which that happens, right? If there's a time at which that happens, that means this part over here would be 4. So 4 equals negative 5t squared plus 5t plus 2. So that would mean that a height of 4 happens at some time. Well, let's see if that time ever exists. So I'm going to solve this here. I'm going to factor it, or actually quadratic formula, because that tends to be easier, to try and figure out what t is, to see if t is a real number. So I'm going to have to get this equal to 0 for my 0 product property. So I'm going to subtract the 4 over. So negative 5t squared plus 5t minus 2 equals 0. So now I can use the 0 product property, which really just means I'm allowed to factor this or to use the quadratic formula. I can only use the quadratic formula if this side over here equals 0, or if I'm finding x-intercepts maybe of a quadratic function, so it's originally y, but if I'm finding x-intercepts, then I plugged a 0 in for a y. So let me erase my graph real quick. So now I'm going to solve this for t, and I'm going to do it by plugging into my quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2a. Let's plug in those numbers. Now I need to do some cleaning up. All right, do you see it? Do you see that we have an answer already? If not, I'll keep going. We'll see. Maybe it'll show up to you. All right, so here I'm going to, let's see, negative 5 plus or minus square root of negative 15 over negative 10. See it yet? No? Oh, well, I'm going to be taking the square root of a negative number. We just said a second ago that means we're going to have negative. We're going to have a negative underneath the square root. Means we don't have any real answers. No real solutions. They're all non-real solutions. I can't have a non-real time. If I can't have a non-real time, then obviously this isn't going to give me any kind of answer that is going to, like, at 5 seconds, you threw the ball up. It went up for 5 seconds. You hit 4, and then it came back down. No, not going to happen because my t value is going to be an imaginary number. So I'm just going to stop here. We done. Can't go any further. You know what? I'll go just a smidge further, just for good looks, Negative 5 plus or minus I times the square root of 15 over a negative 10. That's as far as I'm going to go. Because now you see the I, and the I is the imaginary part, and I can simplify this maybe just a smidge, but not much. A lot of people will cancel the 15 and the 10. You can't do that. 15 needs to have the square root taken before you can simplify, so there's that. But this is as far as you can go, and there is no time, so no doesn't reach 4 yards. Doesn't reach 4 yards. Because again, my time was imaginary. All right, let's go into the next example. Okay, now in this one, what value or values of B will cause this thing to have one real solution? You could go back and look at that slide I had up that had the cases, right? But I'm looking at my discriminant. One real solution means if I have my quadratic formula, plus or minus this square root b squared minus 4ac. Yeah, sing it, folks. It's good for you. Our middle schools teach them a song. I don't know. So negative b, and then if it's plus or minus 0 over 2a, then this is just one case. If this here, this number here in that box is anything other than 0, I have two cases because I have to add something and then I have to subtract something, and it's going to be different. But if it's 0, I only have one case. So I need my discriminant to equal 0. I need b squared minus 4ac to equal 0. Well, let's plug in what we know and then solve for whatever b is to make sure that it equals 0. I don't know what b is. I'm going to leave it as b, but I know what a and when I know what c are. A is here and c is here. So I have b squared minus 4 times 2 and times 18. And then that's supposed to equal 0 so that I can figure out what b is. And let's see, that's 36 times 4. Better do that math off to the side. All right, 144. So b squared minus 144. That's going to be cute for us. That's good. I'm going to add over that 144. So b squared equals 144. Positive now. That's good. Square root both sides, and I end up with b could be plus or minus 12. Right? Because the square root of 144 is a positive or a negative 12. And let's double check that a little bit. So I plug a negative 12 in. I'm going to square it and it gets to be positive. I'm going to plug a positive 12 in, square it, and it's still going to be positive. And then all of that together is going to get me square root of 0. It's just 0. Awesome. So that gives me one real solution. There are, in fact, two answers. Both of those. All right, folks, and that is it. I hope all of you have a great rest of your day. Remember to not do drugs and to make sure you do your homework carefully and with enthusiasm. Bye, everybody.